Chase Berry for three. Rebound by Peyton Crispin. He's going to put it back. They got it! The Lakers hit a three.
Okay, welcome back again. Music Park, home of your SWOCC Lakers.
Can't get the shot to go. The Lakers win the ball game. Go! Lakers win! Lakers win in overtime. 108-106.
Do you like to work with metal, fire, electricity? Would you like to make money doing it? At Southwestern, we can help make your dream a reality. With our degree and certificate programs in welding, you'll be prepared for a career in the welding and fabrication industry in as little as a year. Check out our website and let Southwestern spark your career in welding today.
Southwestern Oregon Community College gave me the opportunity for a new career doing something I love. I'm Amber Yardley, and 3 years ago, I knew I needed to make a career change for myself and my family. With the support of staff, my academic advisor, and the instructors at SWOCC, I now have a dream job and the confidence to continue my education. Contact Southwestern Oregon Community College and start the journey to your new career today.
This is Southwestern's Dental Assisting Program. In just one short year, you could be a dental assistant. Sign up now for your one-year dental assisting certification.
Welcome everybody to our first Physics and Astronomy lecture of the new academic year. Always good to see this many people showing up on a Friday to come celebrate the amount of science that we do in this community and the sciences that are ongoing around us at all times. Today's an interesting case where we're living in a situation where in the next 4.5 to 5 years, we're looking at sending people back to the moon in new sustainable ways and for longer periods of time than we ever have before. And I look at this type of a situation and I look at everyone in the crowd and the students that are in the crowd, the community members that are here, and the types of science that we're dealing with for this mission and for future missions are all supported by people like yourselves, students that are interested in science, people that are interested in science and communicating about science. And one of the things I've been very grateful for since I got to SWOCC was our opportunity to be part of the Oregon NASA Space Grant Consortium. Many of the speakers you've heard me introduce over the last couple of years have actually come from contacts made through that organization, and I was happy enough to hear that the director of the Space Grant Consortium, Dr. Jack Higginbotham, would be able to join us to talk about NASA's future plans going forward. We hope you'll be able to enjoy the talk. Please stick around, and we'll have some Q&A time afterwards. But without further ado, Dr. Jack Higginbotham.
Thank you, Dr. Coyner. Let me make sure my voice is well heard. Can you hear me all out there? I grew up in Texas, but then I moved to Kansas and had the accent beat out of me. And then I grew up, came to Oregon, and I learned that I have no accent anymore. Isn't it wonderful? My name is Jack Higginbotham. When Dr. Coiner asked me if I'd be interested in coming to talk to you. I thought that, what could I bring to you in Southwest Oregon that you don't already know about yourselves? You live in one of the most pristine, ecologically perfect places in the world. If you ever thought about that before, you should, because you are in the best place. My background is in actually nuclear engineering, of all things. And in my early career, I spent some time doing atmospheric work, looking at ways different particles can be distributed across the northern hemisphere. And it was in some of those research models that I was running that I realized that the safest place to be at the time, 1978, when a large nuclear exchange occurred across the world, would be in Brookings, Oregon, because the weather patterns would prevent all that material from coming here. So at the time, I remembered thinking, I wonder if I could ever get a job in Southwest Oregon. Well, here I am. This is great. What I want to do tonight is to talk a little bit about what's going on in Washington, which has been happening now for about 6 months. And I'd like to bring it to your attention because, I don't know that many of the American groups are aware that NASA has decided that we're going to go to the moon, and that we've actually seriously begun that process, okay? And I also wanted to make sure that you are aware that Oregon had a big role to play in the last time that we went there, okay? We trained many of the astronauts that actually landed on the moon in the last cycle of exploration. They actually came through Oregon and learned how to do their job in such a barren environment. You also had the opportunity to have an astronaut named Stuart Rosafly fly as the command module pilot of Apollo 14. And when he went there, he took seeds from the various trees across the United States as provided by the U.S. Forest Service. And he brought those seeds back. They were actually grown to full maturity, and they were given to different places across the United States. We have a number of those in Oregon right now. My campus, Oregon State University, has one. University of Oregon has another. There are grafts of those trees in some other places, like in Cave Junction. But they're around here in Oregon, and it's an interesting idea that it just came to me a few moments ago in talking to one of your civic members. I did not know until a little while ago that the seeds for those trees that were Doug fir trees actually may have came from across the street from my horse arena. And so I'm very interested now in doing a DNA sequencing of all the Doug fir trees that we have to see if I have a common mother tree that may be planted across the road from my house. Now, wouldn't that be wicked cool? So maybe 5 years from now, when I find Mama Tree and I collect seeds from her cone and I send them on Artemis 3 or Artemis 4 to the moon and bring them back, I'm coming to Coos Bay and we're going to plant those seeds together, okay? And you're going to all remember who I am then. I'm the director of the NASA Space Grant Program. Congress created an education program similar to Sea Grant and Land Grant. This occurred in 1988, and they gifted to NASA a program where you could do education, research, outreach in each of the 50 states plus DC and Puerto Rico. So each year, Congress allocates funding for this program, and it's disseminated to each of our states. Oregon State happens to be the lead institution, but we are fully comprised of education, informal education, and a few companies across the state of Oregon to be part of that charge to educate the citizens of Oregon of the opportunities that they can have in aerospace. So I serve as the PI and as the director of that organization. But our real passion, our real goal, our real hope is that we can give young people from Oregon the idea that, you can actually get involved and do these things that most people think are impossible. That if you grow up in Oregon, that you can actually really get to the moon. You can go to Mars. There's nothing in the way except what you fail to dream of, okay? And that means that those of us who precede those young people, we have to open up opportunities for them. And that's what Dr. Coyner and I try to do, and that's what makes our lives exciting, is we inspire some of these young people to say, hey, I think I can understand some of the stuff about physics and orbital mechanics. I can watch the movie The Martian, and I can understand what it meant to turn that spaceship around and go back and get the guy they left behind. Or I can understand what it means to grow potatoes in your own manure. Oh, come on, you got to laugh at that one. Come on. Okay. Again, I have a horse farm. But these are the science problems that space questions or drives us to think about. What's happening right now in the aerospace NASA industry is a very uniform transition in how we approach exploration. So today what I'm going to do, or tonight what I'm going to do, is talk a little bit about this new program that's going apart. I'm going to talk about some of the mission pieces of it to make it happen. But I'm also going to tell you about what the goal is going to be and why we're going to go to this one particular place. All right. So why the name Artemis? Artemis is a name that it's a Greek from Greek mythology. Artemis was the twin sister of Apollo. In Greek mythology, she was the goddess of the moon, so that makes sense that NASA would use that name. Being connected to the Apollo missions, or the last missions to the moon, that makes sense. If you think about it, those of you who have enough gray hair like I do, you remember the program before Apollo was Gemini. That was the two astronauts flying together, and Gemini was a pair of individuals. And then Mercury was the program before that, and that was where the astronauts of the right stuff were selected to be the first ones to be put on a rocket and go off, okay? So in the U.S. history of exploration of the solar system, okay, we started with a Greek program, a Greek god, Mercury. We matured through education, trial and error, design, hard thinking, testing, having astronauts who were willing to put their lives on the line on the chance that they might be able to go somewhere where no one else has gone before. And they succeeded through Gemini. When we entered the Apollo mission, we were unfortunate in that we had 3 astronauts pass away during testing in the first round of that type of that particular mission. But it went on to culminate with Apollo 11, which was landed on the moon 50 years ago, this last July 20th. Apollo 12 was next, obviously. 13, you may know, had a problem with its service module. There was a small explosion, and it had to come back. And if you want to know the drama of that, Apollo 13, the movie, is a real good way to see and get and understand what that meant. Apollo 14, we know now, had this astronaut, Stuart Rosa, on it. The rest of the United States will remember that as the mission that had Alan Shepard on it, where Alan Shepard was playing like he was in the Brookings golf course and was trying to hit a golf ball. Do you remember that? Those of you who watched his show, yeah. And then 15, 16, 17, they started driving carts around, getting out a little bit further from the LEM. Okay. But we learned a lot of interesting things as we approached that. But then towards the end, Apollos 18, 19, and 20 were in mission planning, and Congress said, we just can't afford this anymore. And so we lost the funding for it, and we stopped going. So what's changing now? What's changing now? Why is Artemis going to be different than any of the previous restarts that different presidents have tried to go back to the moon? The second President Bush tried it, President Obama tried it. Both of them did not get any legs under their moon programs. So why is this administration going to succeed, if they are at all? That's a question I get often in the United States when I travel around, is this idea of Artemis is a very polarizing concept to some of the political views in the United States right now. But if you know much about history, what I want to tell you may be a surprise to you. When President Kennedy first announced that he was going to go to the moon, I don't think there's an American, even the younger ones in the audience, who haven't heard we go to the moon. We go to the moon by the end of the decade. You remember that? He said that twice. He said that speech to Congress first in May of 1961. It wasn't even picked up by the national press. He talked to Congress because he needed money to do 5 specific things. He wanted to go to the moon, and that was one thing. He wanted to build a network of satellites to forecast the weather better. He wanted to build a constellation of satellites so we could communicate better with each other. He wanted to build a nuclear rocket, which is part of my research, and I've done that already. But those are the things that he was asking Congress to fund. And then it sort of languished. There wasn't a big yee-haw, let's go do this. It just sort of languished in the background. But there was a man in the room at the time. He had been a member of the Texas congressional delegation a long time. He was the vice president for President Kennedy. This was Lyndon Baines Johnson. Lyndon Johnson saw the vision, and he began moving Congress to start drawing the money resources together. And I don't think it was a coincidence that the second time he needed his president to get out in front of some place to say, okay, ask for the money again. I've got the groundwork laid. Okay, we're going to go this time. He asked the president to go to Mr. Coiner's alma mater, Rice University in Texas, and give the same speech again. And then in this version of the speech, President Kennedy says, we go to the moon, return a man safely back to the earth, and do those other things. He doesn't even mention the other things this time. He just calls them the other things. And that's the one that most people know about. That's the moment they say, we're going to the moon. A year later, he's killed, but we're going to go to the moon. It doesn't matter that we're in war, we're going to go to the moon. It doesn't matter that we have civil strife in our streets and many of our cities are burning with rioting. We're going to go to the moon. What's happening is a certain portion of the American industry and civil servants within NASA organization were on that mission. We are going to go to the moon, and we're going to put a man on the surface of the moon before the end of the decade. And that drove everything. Okay. Once it started, it wasn't something that would stop. Okay. Artemis was announced by Vice President Pence a little over a year ago. Had a small buzz. The idea, the vision is that we will return an American astronaut to the surface of the moon. She will step on the south pole of the moon by 2024. Very specific. There was a pronoun reference in that. It's also not a coincidence that Artemis is the sister of Apollo. The mission title even implies that the next American astronaut will be a member of our current female astronaut corps. When they made that announcement, there was actually a member of that corps who was holding the microphone doing the public interview. She had no idea that the NASA administrator was going to announce that. And she almost dropped the mic because she realized she was one of about 14 people that have a chance to do that. They're not going to recruit another astronaut corps. One of those ladies is the one that's going to land on the moon. And that was exciting. She just happened to be at the right place at the right time. But how are we going to get her there? Okay. Number one, we're going to go to the moon. We're going to go to the moon not just to visit. We're not going to go there and plant somebody and say, come back, because that was the problem with Apollo. We went there, we achieved the goal, then what's next? Well, there was no what's next, and so we canceled the program. This time we're going to go, and we're actually going to set up a way that we can go there again and again and again and again. And we're going to build the infrastructure to do that. The United States has led a coalition of international partners to build an international space station. That space station has been orbiting the Earth and had a person on it for the last 20 years. Okay? We can do this as an international community. The idea is that we'll get international partners to build a similar station in orbit around the moon. That it will then be the receiving point for astronauts, kekonauts, cosmonauts to fly to. Then they will have a lander already there. They could transfer to a lander, land on a specific part of the moon, do a science mission, then return back to the gateway, the satellite, the station around the moon, transfer back to their return vehicle, then go back to the Earth. That's the mission. So the pieces of that mission are going to the moon, there's getting there, that's SLS. That's the launch vehicle that gets us there. This is the next version of the Saturn V, the SLS, Space Launch System. Once you get there, you've got to have, once you get the rocket together, you've got to have a new capsule that the astronauts will be in. We're planning for 4 astronauts now, so we're going to scale up the number that we had in Apollo. It's going to be 4 astronauts. They'll be in the capsule called Orion. Orion exists right now. It's under final testing phase. It'll be man-rated probably in the next year, okay? There's the Lunar Gateway, which is the lunar station around the moon. That will be the ultimate goal. And they'll build it like we did the International Space Station, a piece at a time. They'll launch an initial core that will be there with engines that'll keep it in station keeping. The next one will be a habitation module. The next will be sample preparation. I think you get the idea. We'll build it like we did the International Space Station. They'll build lunar landers. There'll be more than one lander attached to the Lunar Gateway in its full-out build-out. The reason we're going to go to the South Pole is something that I wanted to give you a value added for being in this meeting today, because I can tell you what the science reasons are for going back to the South Pole. So, the moon. The moon is the goal because, one, it's hard to get to, as President Kennedy said. It tests everything we can do. Humans are very, very fragile. We are fragile. If I don't breathe air, I'm dead in 5 minutes, okay? You've got to provide air to that individual. There is no air on the moon or in space, or even 25,000 feet above us that allows us to sustain our life. We need air. The next thing we need is water. You can't go without water very long, okay? What's the next thing you need? You need a habitat. If you've got water and you've got air and you're freezing to death, you're only going to last a little while. That means if you fall off one of the crabbing boats off the Oregon coast into the water, you're not going to last very long. You need shelter, okay? After that, you'll need food. After a week or so, you're going to have to eat. I am prepared for a month, but, okay. But eventually, even I will need to eat, okay? And you'll have to provide all those resources. How do you mechanically get all that together? We've gotten really good at doing that 263 miles above us with the International Space Station. Can we do it at a distance like the moon? We don't know yet. We haven't proved that. That's what Artemis is going to do. Can we do this in a sustainable way to advance science to get us to the moon? The other thing we're going to do is something that happened under President Obama's administration. NASA recognized that part of it had been created to do was exploration. It wasn't a government agency that was here to do launch services for commercial opportunities. That wasn't its function. They began to realize they needed to let go of the federal stranglehold on launch to space, and began encouraging private companies to begin part of the supply deliveries to the International Space Station, and they opened up opportunities for private companies to build rockets to compete against the traditional aerospace companies that did this service for the federal government. It's in that time that companies like SpaceX and Blue Origin came into the mix. In Oregon, at Oregon Space Grant, we heard stories about these young people when they were beginning to work with SpaceX before it was a common name. And we got our students trained to work specifically in the skill sets that were needed in that young company. We abandoned all of our efforts to get students into Lockheed Martin, Northrop Grumman, things like that. We focused on getting these students the skills to put together software packages for control systems, for attitude control, for propulsion systems in the micro scale instead of the mega scale. We got all of these students from Oregon State, PSU, U of O, OIT, SWOCC, to learn these skills. That gave them the competitive edge when they applied to internships at NASA centers to get into those NASA centers for summer internships. Once you've got a summer internship on your resume, then you can apply to these young companies and they'll hire you, okay? Those of you who are in the room who hope that you would get into SpaceX, I'm afraid that door's closed now. They get 10,000 applications for every opening. There's no hope for you to get in there. But we can get you to the next group of companies that are now starting to form because there's now a commercial outlet, and that is the Artemis program. And this last week, contracts have been let with brand new companies I've never even heard of before in Texas and Colorado and places like that that are building the lander hardwares. That's why we're going to the moon, is to build a commercial reason for going. They also talk about Mars. If you've listened to anything that Elon Musk says, he's going to go to Mars and he's going to put people there and people are ready to go. My research is on galactic cosmic ray radiation dose and the consequences on biological organisms. I do not encourage anyone to do this particular mission at this time based on my results. And I'll leave it there. The second thing that has to happen is you've got to build a new rocket. This is the Space Launch System. This rocket is real. This rocket is real. This has been under development since the beginning of the Obama administration and has been making steady progress. All the components have been put together, all designed, they've been tested. The entire rocket stack is ready to actually be flight tested. 2 weeks ago, NASA let the contract to the consortium of companies led by Boeing Aerospace that is building this. They let that contract to order 5 of these rockets. So this is real federal money. We're going to have 5 of these machines. Okay? It has a central stack of liquid, fueled, and oxygen. It's got the side solid boosters like you saw on the shuttle system. Okay? It will lift more than the Saturn V system did, but it'll get us onto a lunar trajectory. The next piece is the Orion space capsule. That's the front end of this picture. This is real. This has already been designed. It's been actually constructed. It's under testing to man certify it right now. That means that you burn it, you drop it, you drown it. You do all of those kind of things. It's in that sequence now. They've also contracted with other companies to build similar types of man-rated capsules in case the Orion system doesn't play out. SpaceX got it very far ahead of NASA on this one, and they actually tested theirs earlier than NASA was able to do with this one. They had a problem on one of their testing programs, and some of the rocket propellant around that capsule detonated. And so they're trying to go back and figure out why that was. So they're on a hold pattern right now as they try to re-engineer to prevent the failure that happened. But that's what testing is about, is to find out what your weaknesses of your design. I thought it was rather ironic that they repeated the Apollo 1 disaster. The other piece of this picture is the service module, the back end with the solar panels on it. This part of the Orion system is not going to be built by the United States. It's being built by our international partners. European Space Agency is charged to develop the service module, and they are well along the way to getting that part done. So the United States has the Orion capsule. European Space Agency is doing the service module. Why would NASA give up the service module? Well, watch Apollo 13 again, and you'll see why we let it go. Again, that was a failed joke, okay? We're not very good at doing service modules. We've had one of 13. Okay, never mind. Lunar Gateway. Lunar Gateway, this is not real yet. This is still in early design phases. I see various pictures coming out of the different NASA centers as to what this is going to be. There's a commonality in them. There's a docking port similar to what we have on the International Space Station. They'll use probably all of that same technology. There's no reason to reinvent the wheel. The habitat modules will be cylinders like they are on ISS. These match up with the third stage dimensions of the SLS system to get it up into that orbit. It'll be solar powered as well. Again, that's technology we've proven for the long term on ISS. So we're not going to reinvent a lot of things we already did for ISS. We're going to build newer hardware and replicate it again. They've also contracted with commercial companies to launch and develop some of these modules as well, and those contracts have been built. So for right now, today, this is still not firmed up, but is under development. This won't be fully deployed until the 28, 29, 30 time frame. Okay, we're going to go to the moon first in 2024 with a direct launch. She'll step on the moon. will go, yay, Americans, we'll plant a flag. Second person will come off, that might be a Canadian, I don't know. We'll find out. I'm sure there's been a political acceptance as to who comes off next. The landers is still way out there. That no one's come up with a final design concept on this one. Bezos, the owner of Amazon, did a PR event a few months ago to try to get the lock on this, and he announced the Blue Moon lander that his group, Blue Origin, had been working on. He has now successfully wooed a couple of traditional aerospace companies into partnership with Amazon, and they have submitted their bid to build one of the models for the lander. There's another consortium, again led by SpaceX, who have been charged and been given contracts to develop a separate design for a lunar lander. They may end up with two different designs. Well, that's still to be determined. But we're in the 1964 to 1966 time frame of the Apollo mission, because the same process was used back then. At the time, Grumman Aerospace came out was the winner to develop the LEM that we all know about. I don't know the next name. It may be both Blue Origin and SpaceX. It may be one of these other small companies that are starting out of these other places. They've all got contracts. The last thing I could do as of this afternoon is I found 7 unique subcontracts that have been let to design this lander. So this is still in quite a bit of fluid state. Why are we going to the south pole of the moon? I hope when you came in you saw that Dr. Coiner left some things out there for you to take home for yourself or for your grandkids. One of those is actually a balloon, a Mylar balloon that has the craters of the moon on it. Get it blown up with helium or just blow it up, put it on the string. But then I want you to spend some time looking at it and look at the different craters of the moon and see if you can figure out where some of these landing sites might be. But the reason we're going to the south pole of the moon is something that's evolved very, very recently, okay? This happened, and this is what I can provide you that you wouldn't know. In 2006, I was sitting in Washington, D.C. at a conference and having dinner with a gentleman who's my counterpart. He's the director of the Rhode Island Space Grant. And he's always been a very interesting gentleman to talk with. He's in his early 80s right now, but he's very vigorous. And he was just bouncing. I mean, he was excited, and I was like, okay, so what's going on? Something's happening. He goes, I can't tell you. I said, okay, well then sit still. And he goes, no, I gotta, okay, you can't tell anybody because, the information's actually still under wraps. And I go, okay, what are you talking about? What I knew at that time, and what I'll tell you now of his backstory, his name is Pete Schultz. Peter Schultz, it was the principal investigator for the L-Cross mission that had just completed its mission at the moon. In 2006, NASA wanted to send a satellite to the moon to map the moon in greater detail than we had for the Apollo missions. So one of the first steps towards returning to the moon was to get better maps of the moon. So they launched Lunar Reconnaissance Rover. This satellite still continues to operate around the moon and takes very, very detailed pictures. If you've been paying attention to the aerospace news of the last year, if you've geeked out on it, you know that Israel almost landed something on the moon. Did you know that? Israel had a small company that was able to launch on a SpaceX launch vehicle, and after 30 days, it got to the point where it was ready to land on the moon. Their Prime Minister, Netanyahu, and his wife were in their mission control. This was not sponsored by the Israeli state. It was just a group of really geeked out engineers and physicists like Dr. Coiner and I, okay? And they almost did it. They had a failure right at the very end, and it crashed. Oh. But Lunar Reconnaissance Rover proved that he did it by taking photographs of the crash site. Okay. Somebody else, another country, recently landed on the moon. They landed on the dark side of the moon. Do you know this country? China. I heard it over here. China recently landed on the dark side of the moon. They deployed a rover, and they went crawling around on the surface. They actually planted a seed. So my little story at the beginning is based on this Chinese story. They actually planted a seed and it germinated. They're not very good gardeners. They forgot to water it and they forgot to provide shelter and it froze to death in a couple days. But the point is it lived, you know. So that was pretty cool. So we're not the only ones going there. But they didn't go to the South Pole. What was Pete Schultz so excited about? Well, his information was embargoed from public release because the science article that was being published was in Science magazine and ready to be coming out, and he was supposed to keep quiet. What he was so excited about was the mission he was responsible for was a secondary payload on the L-Cross mission, called L-Cross, that was on the Lunar Reconnaissance rover. L-Cross took the third stage of the rocket that propelled the reconnaissance rover to the moon. Once you do that, the third stage is surplus. They had enough fuel on it to orient its path so that it would strike the south pole of the moon, very specifically in the dark side of a crater, the Shackleton crater on the south pole of the moon. What Dr. Schultz has been thinking about, and Brown University, while it's an Ivy League school, it's not a big research institution like Oregon State, okay? And please tell your friends I've compared Oregon State to Brown, okay? I just did that, yeah. But he doesn't have millions of graduate students behind him. He was just puzzling us out. He's just this old guy going, you know, if there's water on the moon, which we know there's not from the Apollo data because he was young and he did the geochemistry of the Apollo results, he knows there's no water on the moon. But if it is there, where would it be? Well, our thinking of the formation of the moon is that it would be, there's no water there because there's no atmosphere. It's directly illuminated by the sun. The sun goes through this 10-year cycle of bombarding it with solar particles. So if there's any water there, it'll be vaporized off. So where would the water be if it's still there? It would be in places where the sun don't shine. And the sun don't shine because the moon, when you take your little balloon out there and you roll it around your grandchild's head back and forth, you've got to keep one side of the balloon towards the kid. Because you know, you and I have seen the moon traverse around the earth 700 times in our life. Did you know that? Well, you live in Coos Bay. 537 times have you seen it because the clouds come in about a week, right? But you know, you've got the same face of the moon coming at you all the time. That means there's certain craters on the moon that are forever in shadow. And he thought, if water does exist, because it has not vaporized off from the impact of the sun, it'll exist in these shadows. He convinced NASA that this might be worth using this piece of trash that you're dumping on the moon anyway. Move it over here and hit this dark spot. And he and a bunch of his graduate students, and actually undergrads as well, designed a research satellite to look at the material that was ejected from the collision of that third stage with the south pole of the moon. And with the sun illuminating that plume and this machine looking at it, you can actually use a spectrometer and identify the elements in the plume, ejecta. And you could identify water. And so this third stage went flying in. Just before it got there, it with a spring actually popped loose its little observer satellite. It impacted the moon. Ejecta came out of that shadowed area away from the moon. The sun was shining on that. The satellite looked at it. And what was so exciting for this man at the twilight of his academic career is he discovered water on the moon. That's game-changing. That's a phenomenal science. That's why he was acting like a fifth grader to me. His whole life had just come to that one moment when he got to see water on the moon. We're going to the South Pole because what did I tell you we needed first if we're going to survive? Air. Air. You can get oxygen from water. You can take it and break the water molecule apart and you've got air. What's the second thing you need? Water. If you can find water on the surface of the moon, and if there's enough of it, and you can chemically separate it, then you can live. Where do you need next? You need shelter. You can bring shelter along with you to some extent. Dr. Coyner's research that he leads his students in right now at SWOCC is to look at the cycles of the sun's emission of particles from space. Those particles are also radioactive particles in the sense, and they cause risk to these astronauts. So using that kind of data, people like me will figure out radiation shields. Basically, how far do they have to burrow under the ground, and they can save themselves from that. All right? But you can see why we're going to the South Pole of the Moon. If we can find water there, and if we can learn how to use it, we may find analogs on Mars as well, where we can find water and we can use it. And we're going to live off the land. We're going to live off the land. And that's where I wanted to finish my story with you before I open to questions, as that's how Oregon was formed, remember? Many of our family members can trace some of their roots back to the Oregon Trail, where they moved from the east side of the United States to the west side of the United States. In order to do that, they had to take risk. They had an idea. Somebody told them there was a place that they could have a farm for themselves. They gathered up some corn and stuff, and they put it in a little wagon, and they went trooping along, and they drank water along the way. They hunted along the way, and they got lighter because they lost weight along the way, but eventually they made it. But that's what exploration is. And Artemis is the next phase of the American exploration mission. And I hope you can get the message that Oregon students from Southwest Oregon who go to SWOCC can have a chance to be part of that exploration as well. So that's what Artemis is, in case you hadn't heard of it. I'll give you some reference, because I'm a professor, so teach kids how to do referencing, photocratics. You can't just take a picture off the web and not give credit. So those of you who are still doing college work, you have to do this kind of thing, okay? There's a URL at the bottom of YouTube, which is a NASA propaganda film. So those of you who have got your phones out, take a picture of that and show that to your parents and your grandparents tonight, and you'll see why Artemis is a really cool thing. Okay. How do you want to do the Q&A, Dr. Coiner?
Set it up real quick. Basically, thank you very much for your talk so far. As far as the Q&A goes, if you have questions, raise your hand, and my volunteer assistant here will gladly bring you the microphone. The microphone allows you to actually be heard not only here but on the stream, so those that are watching at home and in other places can actually hear the questions as well. So, we have a question.
The question is, how much of the space launch vehicle, the SLS, is going to be recoverable? The SpaceX model is that they want to recover some portions of it for reuse, and that's where you see the boosters come, and that's phenomenal. They land together, but there's no portion of SLS which is currently designed to be recoverable. It's a fully expendable rocket, so that's what happens. While the microphone goes to the next question, I'm going to follow up on yours a little bit. Why Oregon is important to this? Oregon Space Grant, I mentioned, we got involved in trying to figure out how to get kids at these NASA centers, and we were successful. There was one kid named Victor Dang. He grew up in Portland, Oregon, graduated there, went on to get a bachelor's degree at Oregon State in mechanical engineering. He was one of the first engineers that SpaceX hired. He's the lead engineer for the landing gear of the Falcon rockets. So whenever you watch a Falcon rocket land on one of those drone ships or back at Kennedy Flight Center, I want you to remember my words. The landing gear system is designed and led by a 34-year-old engineer educated in Oregon. So when I say you from Southwest Oregon be part of space, I mean that. Victor Dang is my proof. What's the next question?
Well,
yeah, sorry.
How long will it take for near rectilinear orbit to become unstable, and how do we intend on correcting it?
Which orbit?
Near rectilinear halo orbit.
The question in the front was, what's that in English? I'm echoing that question back to you now. You tell us what you mean by rectilinear orbit.
My understanding is that the Lunar Gateway's orbit intends to oscillate between 3,000 kilometers above the moon's surface and 7,000 kilometers away from it.
Right.
So that way it'll be stabilized between the the Earth and the moon's gravitational bodies.
Mm-hmm.
Is that understanding correct?
Get that up front? No. Yes, sort of. Okay. What he's talking about is what we teach in physics classes and in high school. Remember this guy? He had an apple drop on his head. You know his name?
Newton.
Newton had this thing that he figured out about how gravitational force can be calculated from between two bodies, right? So if you've got a mass 1 and a mass 2, there's an inherent gravity force between them, and it's related by the inverse square of the distance and a gravitational constant g. Okay? Between the moon and the Earth, okay, if you put the gateway in the middle there, you now have 3 masses, okay, and I'm not going to start juggling. I'm just going to hold it in one dimension so it's easier to understand. There's a point between these 2 masses that gateway is going to be at, where the pull of the moon equals the pull of the Earth. And there's no net force there. If you can get it in that location, it'll just sit there. Okay? And so as the Earth and the moon move around the sun, that space station will stay in that little spot. Isn't that wicked science? That's amazing science. That's why you've got to watch the movie The Martian, is because there's that really magic spot. It's called Lagrange point number 1. You can calculate what that is. I gave that as a problem to his college kids today. What has happened is that once you have that point of stability, you can actually orbit that point of stability as well. Okay? And that's what Gateway is going to do, is to answer your question, is yes, we can figure out that stable orbit. That's the basic premise of where Gateway is going to be.
Yeah, but won't it eventually become unstable over time?
No, well, it will be, but we don't care, right? Okay. Because the small perturbations in the orbits and the masses and the non-spherical system, that will all be non-perturbing. But we've got small engines on the Lunar Gateway. They will correct for that. You see? So it's unstable in that over hundreds of years or even decades, it will disappear from that spot of that orbit. That's fine. But it takes almost no propulsion mass to do station keeping in that kind of orbit. See, that's the advantage of that spot. That is a very, very good point of why we're going to Gateway. That's a very strategic point in the solar system. And if we get there first, we own it.
Dope.
Right?
Hi. I have 2 questions, please. First, I'm just interested in what the geopolitics of the moon are. If we're in a space race like with China, I understand they're going full force to try to beat us at a lot of things on the moon. So I'm interested in that. And I also heard that when that Israeli spaceship crashed, that there were Tara guards on board. Mm-hmm. Do you know anything about that?
I do. I do. First question, geopolitics of the moon. Well, we can talk for that for quite a while. There's international treaties that are similar, and they were formed in the 1960s around the precedents that were set for exploration of Antarctica, where none of us could actually own it. We could go there for science research and things like that. It's an open question, still is, in the international legal world, as to who actually owns the resources on the moon. And I hear arguments all over the place on this one, and I don't know that there's really an answer to that yet, to be honest, because we've been able to ignore it for 50 years. Because we haven't been there since 72. It's kind of okay, all right, well, we can fight about it, but that's left for professors to fight, because, professors fight about nothing anyway. So, but now it's becoming more essential. I'm not sure what the answers are going to be, and we're going to have to start asking these questions. And so there are people who think that, well, you know what, I don't care what the answers to the questions are, I'm going to go. And I don't care if you're going to say I can't go, I'm going to go. Do you know who's going to land on the moon, he said, by 2023? 1 year before NASA. The chief executive of SpaceX said that their new Starship rocket will land a man on the moon by 2023, 1 year before NASA. He's going to go. And he doesn't care. He's South African. He's got enough money. He can build his own rockets. He owns Tesla. It's the biggest auto company now. I mean, he's got a guy who's competing with him who bounces, depending on the stock exchange, to being the wealthiest man in the world or not, and the owner of Blue Origin. I mean, the economy of space is drastically changed now than it was 50 years ago. There's a subset of people with the financial resources to actually garner and answer that question by simply being there. So it may be academic as to what the political forces would be when you actually take possession and you land there. Okay? And that's back to the question for the man in the row before you, is if you own that L1, you own it if you're there. And somebody's going to have to push you away. That's an act of war. Can't do that. Okay. Second question, which I just drew a blank on. Help me again. Oh, the tar bots. Yeah, actually, we did research with those here in Oregon. I sponsored a research project for a high school up in McMinnville, Oregon, and they actually put some on the International Space Station. That was pretty cool, and they got to watch them grow, and then they returned, and they watched their death rate, which was a normal death rate. Yeah, they're an organism which is very hardy. It can last in very, very extreme environments, both in dryness and in temperature, and still survive. So one of the payloads that they had on their satellite was this microorganism to see if it would survive in the environment of the moon. And so, yeah, they were part of the crash, and they're there. Maybe someday we'll land there. They're too small for Lunar Reconnaissance rover to see, but it may mean a Chinese robot or somebody or one of our people can land there and pick them up. But let me ask that extension to your question, though. How much is too much? I mean, with all of these entities we're talking about, maybe in 10 years it may be fun that we've got one contaminated spot, but maybe when we have 50 contaminated spots, or what when after 100 missions go to the south pole of the moon, what it's going to look like. And there are some really big questions there about, do we have the right or the authority or the moral conviction to contaminate a different spheroid of the solar system? And that kind of question is starting to happen in the deep infighting of faculty in the United States. It hasn't gotten to the public yet, but those are fundamental questions. And if you read Science magazine, which I'm probably sure none of you do, but if you do, great for you, but you'll be seeing an article from Professor Pete Schultz on that very subject in the near future. Should we even go from that position? Okay.
Yes, hello. I wanted to ask you if you have had any contact at all with Dr. Paul Hellyer, Hellyer. He has a YouTube that I was hoping to share with the youth here in Techno Geeks. It's Paul Hell, Hellyer. It's a YouTube.
You're teaching me now, so.
Okay.
So I was wondering if it would technically be, well, this is just more of a confirmation question. I was wondering if it would be easier to launch a rocket from the moon at the
Yes.
If it would be easier to launch a rocket from the moon, basically. That's my question.
That's right. It is actually. The escape velocity from the gravitational field of the moon is much lower than leaving the gravitational well of the Earth. That's one of the advantages of getting to the moon and building a reclamation facility that can produce rocket fuel. If you can take that water and separate the oxygen for the humans to live with, you also release the hydrogen, which you can then reform into a rocket fuel. And over time, you would develop enough of that you could fuel a rocket to go to Mars. And that's exactly what the plan is, because it takes less money, less energy to get out of the lunar gravity well to get to Mars than the Earth gravity well to get to Mars. So it actually saves us resources to be able to do that. Very astute question. I like that. We have a question down here in front.
All right.
Over here.
Excuse me.
Oh, I understand, yes.
Great presentation, sir.
Well, thank you.
At the present, my wife and I are watching the National Geographic production Mars. It was done a couple of years ago. I was wondering if you were familiar with it and what your take on the science is. Because aside from being a docudrama and, of course, an exercise in Murphy's Law, it seems to be pretty authentic.
Is there a particular part you want me to address? Let's do it that way.
Oh, okay.
I mean,
Anything that really jumped out at you is that ain't going to happen.
Bad science. Hate bad science.
What's that?
Hate bad science.
You hate bad science?
Yeah, when the movie industry gets a hold of that and presents something that's not terribly plausible.
Right. You know, it's very difficult to communicate the nuances of the science at times, and that takes an immense skill, and it takes time for people to develop that skill. To answer the question of the rectilinear orbit, I appreciate your willingness to engage in helping us to understand, to develop a common vocabulary to be able to answer that question. Okay? So sometimes in a dramatic expose, the writers, in my observations, the writers and the performers have to try and present the science in a way that will be understandable to an audience that you don't necessarily know.
Sure.
Okay? Mm-hmm. So you and I have the advantage with the gentleman in the back that we could work together in this real-time moment to come up with an understanding of how we can communicate. But in the docudrama format where you're a passive observer, it's hard to make that leap. So while you may think of it as bad science, because you know more than what the actor is trying to tell, okay, I don't necessarily agree that there's always an intent to hide that, or it's not an explanation, but it's an attempt to try to deliver a very broad information set, to a general audience, and that's not easy to do. So I understand what happens. For me, the easier one to describe this is the movie Gravity, with Sandra Bullock. That one, Neil deGrasse Tyson and I agree. That one was, we're a bit more aware of microgravity and orbital fluids and mechanics and stuff, and that was not real mechanical stuff, and it kind of took away from the story for us, but they didn't we weren't the target audience. So, we can go through it scene by scene in that movie, that docudrama you're talking about, and we can talk about specifics of the sciences being presented, and you and I can come up with an understanding of whether it's deep enough or not.
It seemed pretty solid.
Non-segue. Are there standout lessons learned from the ISS that are going to build confidence in building the lunar equivalent of the ISS?
Excellent question. The answer is absolutely. Absolutely. In my own field of research in ocular acuity, one of the problems that we've discovered is that astronauts, particularly men, when they're in a zero or microgravity environment for 6 months, the eye itself, the organ of the eye, actually becomes more spheroidal than it is in a gravity field, and your visual acuity is actually impaired. And then when you return to the Earth, men particularly don't have their eye reset to where it was originally, and they lose some visual acuity. For reasons we don't understand yet, the female astronauts that have gone on similar flights with same durations, they don't seem to have that deficiency, and we don't know why yet. So we've learned a bit about that. That's one of the reasons some people then make the big leap, well, only women need to go to the moon. Well, okay, you can't do that science, but it's definitely sufficient because Artemis is the name we're going, and we need a woman to go. That's enough. But we've definitely learned how to live in microgravity. We've learned that the space radiation that they can receive in a 1 year in low Earth orbit, we understand that that's a survivable dose now. And we can do that within a 3-week or 3.5-week time on the surface of the moon under low solar activity. So there'll be no real long-term radiation effects if we live within that restriction on the moon and then bring them back home. So yes, we've definitely learned about some of those are some of the examples about ISS. We've also learned the mechanics of how to purify water. You know, so we take all the water from the astronauts and we purify it and we give it back to them, so we don't have to lift it up there anymore. So we've developed that technology. So when we can get the water out of the rock of Shackleton Crater on the south pole of the moon, we can conserve it and not lose it. Okay, those are small examples. Does that answer some of your curiosity? Okay, great.
I was going to ask if you knew where the explosion on Apollo 13 was.
Where it was?
Yep. On the spaceship.
On the spaceship? It was in the service module. On Orion, let's see if I can go back. On the Orion capsule that's going to the moon now, I think you're familiar with the solar panels that come off the side. Those solar panels are generating electricity for all the life support communications on the spacecraft. During Apollo, we didn't have solar panels of that technology yet, so they used another type of material, another machine to do that could actually create electricity. And that machine took oxygen and water and hydrogen and recombined them into water. So you had oxygen stored and hydrogen stored, and you recombined them into water, and that generated electricity. Those two materials, liquid hydrogen and liquid oxygen, are very cold. And to prevent the pipes from freezing before the materials could be recombined into electricity, you had to stir that liquid around to make sure it didn't form solid ice inside, or solid material. And when the astronaut actually gave a signal for that stirring mechanism to actuate, there was an electrical short in the wire that actually caused the oxygen to detonate and explode in a very rapid chemical reaction, and it blew the side off of that service module. So in the photograph that I show you here, imagine one of those solar panels, how it's attached to the side of the service module. That whole side would blow off. And because that was also the source of their oxygen, then they didn't have enough oxygen in the capsule to survive coming all the way back to the moon. And that's why they had to crawl through into their lunar module where they had an oxygen storage facility, their lifeboat. And they were able to survive on the oxygen reserves of the LEM. So that's where it happened. Did I answer your question okay? Okay. Good question.
I'll hijack my own Q&A for a minute because I actually had a couple that came up. I want to follow up on one of the questions that was asked before, and then I've got one from my own perspective. But when we talk about the L1 Lagrange point for the Earth-Moon system, one of the examples we can use to look at that is the SOHO satellite that works with the Earth and the Sun. We've all seen images from SOHO of the Sun for the last 27 years, and part of that is because that satellite is in the L1 location with regard to the Earth and the Sun orbit. And we have a satellite there that basically just stares at the Sun every day and takes countless number of pictures and basically used to pay most of my rent, but it doesn't anymore. But
that's because you get paid so much here in Southern Oregon. That's why.
No comment there, but we'll move on for the time being. The one other question I did have, because we mentioned the radiation survival for being out there that long. How much research is currently being done, I guess, in connection to the twin study with the Kelly astronauts that Scott Kelly went onto the ISS for a year and Mark stayed down here. And I noticed some of the early reports have shown things like some of the DNA sequencing has been somewhat manipulated because of the radiation exposure and various other things. But I don't know enough about what all is going on. I don't know what types of changes and protocols are being adjusted to try to shield from that radiation.
Right. What he's describing is that there have been two astronauts in the U.S. astronaut corps who are actually twins of one of the other. They've both flown in space. The second one did a mission on the International Space Station for a full year. He has more space time than anyone except for 2 Russians. When he returned, they did because his DNA is identical to his twin, they did this DNA testing to see if there were any differences between he and his twin as a result of his being in space for a year, and they have identified some differences. I don't know that I would say that they can target those differences as arising from radiation exposure. I don't know that we know that yet. It may be some other mechanism that's causing that difference, but there is a difference, and it seems at some level to be recovering as he stays in the gravity field a little longer. He had many other physical changes that more extreme than we've seen before, and we're still studying that. He himself, it's difficult to talk about for me because in my world of university level research, we have rules that keep the identity of our test subjects private. Okay, so that when we do our research, we can't identify who the individuals are that are part of our research program. These rules are put in place to make sure that reasonable ethics are followed when you're doing research with human beings. In this particular case, because of the very public nature of the 2 subjects, it's awkward to talk about. But the second Kelly, the one who flew, is having some significant mental acuity issues, visual issues, blood pressure issues. So it's not just the DNA. He's having a number of other physiological consequences of his long-term duration mission. Our counterparts in the Russian medical field have seen the similar kind of behavior or responses in their cosmonauts as well. So are we learning from that part of the question, Dr. Coiner? Yes. That's why we're going to limit for a while a month of stay on the moon, as being replicative to 6 months on ISS, at least from the terms of the radiation, the microgravity environment. And we'll develop a new set of standards as we live longer and longer around the moon, which will form the basis of our standards when we move to Mars as to how long we need to make that trip. If we can't do it in a 3-year period and we need to do it fast, and we need to go back to what President Kennedy said in May of 1961, we need a nuclear rocket to get there fast and get back to be able to survive. Did I answer your question, Dr. Coiner? Okay. Yeah, I'm just stalling until your legs get over there. Yeah, This young man and I are starting to get into this. He helped me with another talk I did earlier. Yes, sir.
Did Russian intelligence let you know of everything that could happen in the U.S.? Did they still basically send a man out there and have the same problem that they warned them about?
The answer is yes, they have. The Russian scientists, are similar in their. They have access to the documentation of the Soviet systems as well, and so they had an idea as to what we would see, but they only had 2 or 3 examples of it, and so this is a 4th example. So. You can take a measurement and see what the responses are for 1 human, and then to try to extrapolate that to 2, it's a little more difficult. But when you get more data, more samples, you can get more confident of what the biological effects are be. So in some of these physiological changes that astronaut Kelly's experiencing, that they have reaffirmed the information that the Russians had said, this is what we saw. So yes, they have been forthcoming. We are a collaborative science community now, and I think that's really, I've worked in some of that field, and that's actually quite encouraging when we talk about science. It doesn't matter where you're from; it's just science. Okay.
I made him wait till the very end.
Oh, you've got one. No, I'm going to get stumped.
Okay, I had one question, which was, I don't know if we have done this yet, but is there any parts from a space shuttle like Apollo 11 or I forget which one, but that crashed and exploded. Is there any of them that we could pick up the parts and then maybe use them for our newer ones so we can lower the cost budget?
Oh. Okay. That's
No,
right out of the movie The Martian, isn't it? Is there any that... I don't think so, but let me hedge a little bit. Apollo 12, we wanted to make sure we could land on the right spot because we missed our target on Apollo 11 by about 3 miles. It happened to be because we didn't understand the density of the moon varied. Apollo 12, they landed next to the Surveyor lander, which was an unmanned mission that landed in the same spot a few years before that. And I think that, you could have pulled the solar panels off of that one and used them, but, so I guess there's some ideas that come out of that might be worth selling in a fiction book that would make you very, very rich and allow you to write another book called Artemis. Okay, good. We got some giggles from the geeks out there. Yeah, you've read Andy Weir's book, The Artemis, and that he's the author of the Martian book, which did exactly that. But that's a very astute question. We haven't put enough interplanetary hardware out there yet to use that, but I'm sure the way we're going, we'll have so much junk out there that, yeah, we'll be there. Thank you so much for spending some time with me on a Friday evening. I really appreciate that, and for the honor for having been invited to come. Thank you, Dr. Coiner.
No problem.